Good morning to all. Today we are discuss about transient stability analysis of multi-machine power system. Design methods for improving transient stability. First point, improve the maximum power transfer capability. Implement use higher system voltage levels. Second one, install additional transmission lines. Then third one, install lines and a transformer with a smaller reactance values. Then fourth one, install series capacitive transmission line compensation to reduce the overall reactance of lines. The next, install static VAR compensator and a flexible AC transmission system, that is called FACTS. Second one, implement high-speed fault clearing. And third one, implement high-speed recloser of circuit breaker. Then fourth one, implement single pole switching. Then fifth one, use generator with large machine inertia with lower transient reactance. Then sixth point, use fast responding high gain exciters. The effect is to increase the generator output during the fault and post-fault periods. Critical clearing times are increased. Implement fast valving. The fast valving acts to balance the mechanical and electrical powers. This provides reduced accelerating and longer critical clearing times. Then next one is a braking resistor. In power system, area of generation can be temporarily separated from the load areas. When the separation occurs, the braking resistor can be inserted to the generation area for a second or two order to slow the acceleration. Next, to reduce the complexity of the transient stability analysis, simplifying assumptions are made. Each synchronous machine is represented by a constant voltage source behind the direct axis transient reactance. The governor action are neglected and the input powers are assumed to remain constant. Using the pre-fault bus voltages, all loads are converted to equivalent admittance to ground and are assumed to remain constant. Damping or asynchronous powers are ignored. Then mechanical rotor angle of each machine coincides with the angle of voltage behind the machine reactance. Then last one, machine belonging to the same station string together and together are represented by the one equivalent machine. The first step to solve the initial load flow and determine the initial bus voltage magnitudes and phase angles. The machine currents prior to disturbance are calculated from I1 is equal to SI divided by VI, that is equal to PI minus JQI divided by VI, that is equal to I is equal to 1, 2, up to M. All unknown values are determined from initial power flow solution. The generator armature resistance are usually neglected and the voltage behind the transient reactance are then obtained. Then E1 is equal to VI plus JXDI into I. All loads are converted to equivalent admittance by using the relation. Then admittance equal to SI divided by modulus of VI squared, that is equal to PI minus JQI divided by modulus of VI squared. To include voltage behind transient reactance, M buses are added to the N bus power system network. The equivalent network with all load converted to admittances is shown in figure. In the diagram represented for then N bus networks, loads are converted to constant admittances. Then first one is the generator and n plus 1. Then second one is the generator n plus 2. Then last one is the generator n plus m. If the figure represented for power system representation for transient stability analysis in the matrix I1, I2, that is I divided by In plus 1, then up to In plus m, that is equal to matrix formation of Y matrix equal to Y11, Y1n, Y1 n plus 1, then up to yn plus m, then y21, y2n, then y2n plus 1 plus, and then value of the y2n plus m, then yn1, ynm, then yn plus 1, yn plus m, then yn plus 1 into 1, then yn plus 1 into a, then yn plus 1 into n plus 1, then yn plus 1 into n plus m, then yn plus m 1, yn plus m into n, yn plus m plus into n plus 1, then yn plus m into n plus m, that is the value of voltage V1, V2, Vn divided by En plus 1 up to the value of the En plus m. Then I bus equal to Y bus into V bus. I bus means current, then Y bus means admittance, then V bus means voltage. All nodes other than generator internal nodes are eliminated using Cron reduction formula. To eliminate the load buses, the bus admittance matrix in 4 partitioned such that the n buses to be removed represented in the upper n rows. Since no current enters or leaves the buses, current in the row are 0. The generated currents are denoted by the vector Im, and the generated load voltages are represented by the vector Em, and the Vn. The equations of fourth term in the submatrix becomes, that is equal to matrix formation of 0 Im, that is equal to Ynn, Ynm, Ynm into, that is Ymm in the matrix into 2 into 2 matrix, then that is equal to Vn, that is E dash m. So next calculation, then 0 Ynn Vn plus Ynm into Em. Im is equal to Ynm into Vn plus Ymm into Em. That is Van is equal to minus Ynn, then Ynm into Em. Then Im is equal to Ymm minus Ynm into Y inverse of Nn, then Ynm into Em, that is equal to Y red bus, then Em dash. Then reduced admittance matrix is Y red bus is equal to Ymm minus Ynm up to power of t, then Ynn up to the inverse, then Ymm. The reduced bus admittance matrix has a dimension mxm, where m is the number of generators. The electrical power output of each machine can express in terms of machine's internal voltages, then S equal to E into I1 or Pi is equal to Re into Ei into Ii, where I1 epsilon j is equal to 1 power m, E j is equal to Yjj. Then expecting voltages and admittance polar forms, then E dash equal to half phase angle and the Yij, that is model of Yij angle 0 Ij, substituting the for I in resultant. Then Pi is equal to epsilon j is equal to 1, then m Ei into Ej into Yij cos theta my Ij minus gamma I plus gamma j. Prior disturbances, there is a equilibrium between the mechanical power input and the electrical power output we have. That is Pm is equal to epsilon is equal to j is equal to 1 m ei 1 ej ey ij cos theta ij minus gamma I plus gamma j. The classical transient stability study is based on the application of a three-phase fault. A solid three-phase fault at a bus K in the network results in Vk is equal to 0. This simulated by removing K row and column from the pre-fault bus admittance matrix. The new bus admittance matrix is reduced, eliminating all nodes. In the internal generator nodes, the generator excitation voltage during the fault post-fault modes are assumed to remain constant. The electrical power in the ith generator in terms of new reduced bus admittance matrix are obtained. The swing equation with damping neglected for machine I becomes then Hi divided by pi f naught, that is d squared gamma I divided by dt square is equal to Bmi minus epsilon j is equal to 1 m ei modulus of ei then modulus of ej into modulus of y into ij then cos theta ij minus gamma I plus gamma I then y ij elements of the faulted reduced bus admittance matrix. H is the inertia constant of machine I expressed on the common megavolt ampere based on SD. If Hg is the inertia constant machine, I expressed on the machine rated MVA is when the Hi is given by Hi is equal to Sgi divided by AC B into Hgi, showing the electrical power of the ith generated by PEF and transferring into variable model yields, that is though d gamma divided by dt square is equal to del omega I, then d del omega I divided by dt is equal to pi f 0 e divided by h, then Pmi is equal to Pi power f. In transient stability analysis problem, we have two state equations for each generator. When the fault is cleared, which may involve the removal of the fault line, the bus admittance matrix is recomputed to the reflected changes in the network. Bus data V, then gamma, then B load, Q load, then P generation, Q generation. Line data Rij, then Xij, Bij. Generated data, direct reactance and direct field intensity. Determine the bus admittance matrix, and the next one is the power flow analysis and the chart. Enter the faulted bus number. The next one is the enter the line number of the removed faulty line. The next one is a simulation transient process of power system based on that equation 18 and 19. Then last one is the evaluate the transient stability to determine the critical clearing time. Thank you.